Right, I feel I must correct a little bit of misinformation about the Emco Unimat PC little lathe. Certainly it is a good deal larger than the Unimat SL. These bars, which form the bedway for the lathe, are let me just pause that and I'll tell you. I think you might be able to see that just about, if it focuses, about 2 centimeters in diameter, just about spot on 2 centimeters in diameter. If I then look at the bars on this Unimat, then that's about 1, if it focuses there you'll be able to see it as well, 1.2 centimeters in diameter. So a good difference in the bars. The distance between centers, I just had it with a tape measure. Let's pull back a bit. It's about 1 inch greater distance. The swing over bed, well, there's a good, it's almost, let's pull that out. 2.5 inches almost, and certainly over this cross slide you've got a good inch swing. That's 2-inch diameters. That I think, maybe we'll have to check that out. So it's a larger lathe. However, it's not a cast iron bed. There was something that said it was a cast iron bed. The bed on this one is cast aluminium. I think it was cast iron on some models. I believe this is the cast aluminium version. This is simply pressed steel. Let me show you. So there is the underside, and I think that's quite clear to see that it's pressed and welded steel, quite hefty steel, 1/8 inch steel plate, and curled and pressed. So the part that the column fits into, it's not into a milled or drilled or machined hole in a casting. It's through a hole cut into the steel plate there, and a tab on there, which presumably is plenty enough to hold it rigidly. I think there are many videos which show the end of the Unimat PC, which does have a very useful compact arrangement of gears, and you can see the slots here that will allow different size gears to be fit, and what are the axles, what are they called, the pivot points for the gears to be moved to compensate for the different diameters of gears, to give you a number of gear changes. And that's the end of the motor. The motor looks rather small. So what about the large red plastic block on the back of the Emco Unimat PC lathe? Well, you've got your kettle lead mains input, and I think that's the voltage selector set to 220 volts on there. And apart from fastening on with 3 hex machine bolts, the other connector, if I swing over to the lathe, from there is just a one of these type of Molex connectors with a red and a blue wire out, suggesting that you've got a DC voltage coming out of this. You know you've got mains coming in, and that's confirmed when you pull it apart, because your mains voltage goes in. There's a large transformer here, in a completely shrouded in plastic, a bridge rectifier down there, and the capacitor here. The capacitor in this case was rattling about a bit. It's come loose. That needs gluing back down onto there. A little resistor across the capacitor. So that's the smoothing capacitor. That's probably just to discharge the capacitor when you take the mains supply away. So you get a DC regulated, not regulated, sorry, smoothed DC supply out of this transformer. And if I can read the writing on the transformer, we can tell you what voltage it's working at, and whether this focuses or not, I don't know. It's quite faint on this. I'll do a quick photo, try and take a still photograph. Is that taken a still? Not yet. Well, what I can tell you is that it says 28 volts AC at 2.3 amps. The input is 115 stroke to 30 volts AC at 0.56 slash 0.28 amps. I think it's 0.56 amps at 115, 0.28 amps plus or minus 5% at 230 volts, but the output is 2.3 amps as far as I can tell at 28 volts AC. So there we are, and by the time that's regulated, we're talking about depends on how they're measuring the AC with its peak, but you could be talking about 24-30 volts DC out of this little unit here. Quite a heavy chunk of transformer here. There we can see it. There's the settings, 115 volts. Sorry, I'll need to move these around. And then on the output, yes, we can see it under there much more clearly on this. I think you can see it there yourself. 28 volts, 0 volts and 28 volts out with your two inputs there. It's a potted, sealed transformer, so quite a, what should I say, robust item being potted and sealed like that. I'm just trying to remove the top control panel, and if I'm right, then I've taken a screw out of here. I've taken the screw which was part of the hinge on the door out of there, and there's another little screw which can just be seen through the hole in this pulley, the I think it's the back gear pulley, and hopefully if I can undo that set screw, Allen head set screw, then this will come free. I've been straining it, trying to find out where the resistance is in terms of the resistance to removing the panel. So what have we got? Well, we've got these 3 tooth belts. They look to be in good condition, and in general I don't think this has seen too much use. It doesn't look very worn. There isn't the evidence down here of wear. Right, okay, so basically just 2 set screws, one there and one through a hole in this gear, to be removed in order to remove this top panel. The front edge of it is sprung fit with that spring clip there. As you can see, quite a dense little circuit board there. So with a machined aluminium section and just 2 wires coming into it from the DC supply. there is a little bit of a legend on it. Where's that little bit of writing on it? I've lost it. Oh, it's underneath the spring clip. A little bit of writing here suggests that what we've got is something that's set at 34 volts, and it's got a code on it, Emco, not very clearly visible because it's hidden by that. I don't think that's important. So you have DC voltage in and a pair of spade connectors there, which is the controlled voltage out to the motor. And so that is our speed control circuit board, which is mounted in top of here. And then what we can see now that that is off, if I get my elbow out of the light, is the DC motor itself, which is in there, just in a galvanized steel can. You can see the shaft clearly. This part, it's not there isn't a solid cylinder as we have on the Emco Unimat. Let me just flick over to it. Emco Unimat, because that is able to slide with the means of a handle in here, which is useful for the column for the milling. We've got bearing at each end and a solid tube. On this one, what we have is the headstock shaft and a bearing at each end mounted into the pressed steel, or the steel frame of the headstock. So there's the headstock, but made quite strong because there's a U-shaped piece of steel welded between the ends. So an interesting construction in that, if I put pan back, now we've taken that off, quite a big gap at either end. So there's, I don't know what that's for. So instead of it being a solid weld all the way around, this is a not quite a box section, but it's a U-shaped piece of steel in here between these two plates here, welding these together, again in that 1/8, possibly 3/16 thickness steel. Why don't I measure it in millimeters with my, there's a coating of paint on it, but there's no reason we shouldn't just look at it. How thick is that? And that is 4 millimeters with the, is that 4 millimeters? Well, it's a bit less than 4 millimeters. So possibly, as you pull it off, of course, you open up the jaws if you're not careful. Yeah, well, with the thickness of the paint on there, it's not far off being 4 millimeters thick steel, so that's quite thick. So there we have it. That then is your headstock in there. Those two bearings, what's that there? And a welded steel construction, and your DC motor in there. I'm not dissatisfied with that, and it's again, it's reinforced because, as you can see down there, there's a tube of steel carrying the traversing screw mechanism in there, and then the whole of this curved steel here, the moulded curved steel, which forms the rest of the strength of that bodywork, carrying the spars, which hopefully are fairly accurately set into the steel plates to provide you with a good solid parallel movement for the lathe bed. I guess that is something that I'm going to have to check out, but I can't see that they've manufactured and sold something which doesn't have that and I can't feel any play of any description at all in those bearings. But again, I think I said I don't think there's been much use of this. It's got some surface rust. Hope that helps in terms of anybody wanting to know a little bit more about this. I don't intend to strip it down anymore at the moment. I'll consider what maintenance might be needed. I don't even think I need to re-grease the bearings at all, but I will have a closer inspection of those before I put it back together. Thank you. One last little thing. I have downloaded the manual. There's one in German, one in English. I did put a little Tommy bar into the spindle here and try and unscrew by hand. Oh no, I actually put a bar across the jaws in there to try and unscrew it, but it seemed to be fixed tight. That might be just because it's been on a long time and it's just seized a little bit, but certainly the chuck wasn't going to come easily off the nose of the headstock spindle. So I'll have to have a look at what the instructions suggest and then maybe get a good length, good size Tommy bar into the hole in the headstock spindle so that I can try and undo the chuck with a bar pushed down in between the jaws in there. Somebody has already said that the travel here is greater on some of the other lathes. I've no idea what the Unimat 3, Unimat 4 and other lathes are like. It comes with a ready, well, the hand wheel itself has got a toothed section on here. The marking for the micrometer markings here, that's a friction thing, so that you can set this to a certain position and then zero that to allow you then to move in and out, take your cuts, and presumably it's the same on that feed at the other end. Yes, it's the same on that, so you've got the toothed wheel the same. And I noticed on the PC fitting that the pulley on the end of the stepper motor appears to be the same size as this, so it's a straight 1-to-1 ratio between the stepping motor and the position of this. But that again is something that would have to be checked. Let me just say that I'm not an expert on machine tools. All I'm doing is exploring this to learn a little bit about it for myself, because I want to know what I've got and how to deal with it. And I feel it has been worthwhile just doing this little bit of a strip down to find out a little bit more about what I'm dealing with.